Good morning, this is Dr. Turner for Integrated Math 3. Today we're talking about 2.5, which is transforming functions. In Unit 2, we spent a lot of time in looking at what a function is, how we graph different types of functions, quadratic, cubic, polynomial functions. Now we want to look at how we can shift those functions. Some of these topics we've already covered in these previous units, so it should be familiar, but just the same, we'll go over it really quick. In this unit, you're going to be asked, how do you move a function? How do you move it left, right, up, down, so on and so forth? So we'll start out by going back to 2.2 and looking at a quadratic function. Remember that with Desmos, you can always put in the sliders so you can see how each of these variables is being affected. So we'll reset this to the parent function, which is y equals x squared. So if I want to shift this function, and this is going to be true for any function, if I want to move this function up and down, what I do is I change the constant. I change that value on the outside that's not associated with the variable. This also will change my y-intercept for any function. So for any function, if I change k, if I move it up, then the graph goes up. And if I move it down, then the graph goes down. You'll be asked to do specific shifts. So for instance, if I have y equals x squared plus, if I have y equals x squared, let's say, and I ask you to shift it up 3, then you would tell me, well, that's y equals x squared plus 3. If I have y equals x squared and I ask you to move it down 4, and you'll tell me minus 4. This is going to be true for any function. So y equals x cubed, for instance. If I ask you to move that down 2, you do minus 2. Ask you to move it up 5, you do plus 5. So whatever value is on the very right, the constant is not associated with the variable, that's shifting your graph up and down. I'm starting with the parent functions here, but it doesn't have to be. So for instance, if I gave you y equals x cubed minus x squared plus 2, and I ask you to move it down 5, well, it's already at plus 2. So if I subtract 5, that would be the same as writing y equals x cubed minus x squared, and 2 minus 5 is negative 3. Same thing, if I have a polynomial function, let's say I have y equals x to the 4th power minus 2x squared. If I ask you to shift this up 1, then you can just do the same function, but plus 1. If I ask you to move it down 2, then you minus 2. Okay? So that k value for any polynomial function is going to shift your graph up and down. The other thing that is true for any of these functions that we're talking about is the shift of the a term. So a is always your leading coefficient. That's going to be true for quadratic functions, cubic functions, polynomial functions, and they each have the same effect. So if I take y equals x squared here, if I take y equals x squared and I ask you to change the a value, remember that the leading coefficient is going to determine how quickly or slowly the function is increasing. So looking at y equals x squared here versus 2x squared, or 4x squared, or 10x squared, it's causing the function to increase that much more rapidly. And so if I zoom out, I can kind of see that that's what's happening, but if I'm looking at a narrow window like what's shown here, it looks like the graph is being kind of shrunk down, going from left to right. What we call that is a horizontal compression. So if you say compressed or more narrow, I would accept that. In the textbook, it's going to refer to that as horizontal compression. And vice versa, if I start out at y equals x squared, and I decrease the a value, 1/2 x squared, 1/3, 1/5, 1/10. It's increasing more slowly. On the graph, especially if I'm looking at a narrow window like this, it looks like the graph is wider. So we call that a horizontal stretch. And I would accept either of those as a correct answer. A is decreased, it is a horizontal stretch. And if it is increased, we call that a horizontal compression. That's going to be true for any function. So for instance, we saw this with y equals x cubed or any of the cubic functions. Right? If I change that to 1/3, it looks wider. 1/3, 1/5, 1/10. And same thing if we increase it, 2x cubed, 5x cubed, 10x cubed. Horizontal stretch, horizontal compression. That's true for all of your polynomial functions, and a, again, is always going to be the leading coefficient. Likewise, if we change the leading coefficient to be a negative, it's going to reflect the graph no matter what it is. So for instance, if I have y equals x squared, and then I change that to negative x squared, it reflects the graph upside down. Call that a reflection. If I have x cubed and then negative x cubed, it's reflecting the graph. Y equals x to the 4th minus x squared. Y equals negative x to the 4th plus x squared. Changing that coefficient is going to reflect the graph. Going back to quadratic functions for a second, if I'm looking at a quadratic function in vertex form, we can change the graph moving it left to right. We do that by changing the h value. So here, let's say this was y equals x squared, and I change it to y equals x minus 1 quantity squared, then that is shifting the graph to the right. Now this gets a little bit confusing for some students because we're used to thinking of h being positive, or going to the right being positive, going to the left being negative. But your formula, as it shows here for vertex form, is y equals a times x minus h quantity squared plus k. You have a negative in your equation. So if I put in a value of 1, the equation would be y equals x minus 1 quantity squared. So that's just something you have to remember, that looking at the formula, it's sort of the opposite sign. So having a minus 1 there, we'll move it to the right 1. Having a minus 3 there, we'll move it to the right 3. And vice versa. If I want to move the function to the left, I'd be subtracting a negative, which makes a positive. So moving it 2 to the left would be plus 2. Moving it 5 to the left would be plus 5. So on and so forth. In this section, you're going to be asked to kind of put all these together. So I might tell you, take y equals x squared, and give me the equation of a function that's been shifted up 3 units and left 2 units. So you put those two concepts together, that's shifted 2 to the left, that's shifted up 3. You're starting with a parent quadratic function, and I ask you to stretch it by a factor of 2 and move it down 1. You start out with x squared. Stretching it by a factor of 2 means I have to put a 1/2 there. Remember, less than 1 is going to stretch it. And then shifting it down 1 would be minus 1. That's going to be true for all the polynomial functions, so be careful with that. There's practice on the supplemental resources if you feel you need a little bit more help with this. Otherwise, guys, that's it for today. Have a good day, and I'll talk to you soon. Bye.